Hello everyone, welcome to my YouTube class. In this video we are going to see the question on how do we find minimum of 3 numbers, and we will also see why ELSEF ladder is used here. Now how many numbers are there? There are 3 numbers. Let the 3 numbers be A, B and C, and let us assume that they are of integer type and we read the values of A, B and C. Okay, now this is A, B and C. Let the value of A be 10, let it be 20 and let it be 30. The minimum of these 3 numbers is A. And why we should prefer ELSEF ladder? Because there are 3 things. Out of 3 things you want to select one. Now whenever out of n number of things we want to select one thing, we prefer ELSEF ladder. Now how do we know that A is minimum? The value of A should be less than B. Now is this the only case? Can I only conclude that if the value of A is less than B, then A is minimum? No. Why? Because the value of C might be 3. Now what is minimum? Minimum is C, which is 3. Even though A is less than B, A is not minimum. That means I need to also compare the value of A and C. Therefore, what will be the first condition? The value of A should be less than B as well as the value of A should be less than C, then only A is minimum. Hence, we write over here, if the value of A is less than B and the value of A is less than C, yes, the value of A is 10, less than 20, yes, assume that the value of C is 30, 10 less than 30, yes, what is minimum? A is minimum. Therefore, we write here printf A. Therefore, we write printf A. A is printed. Now, there might be the second condition where B is minimum. Let us assume the value of B is 2. Now, you check here 10 less than 2? No. That means if in the logical AND, if the first expression evaluates to false, will it evaluate the second expression? No, because false and false is false, false and true is also false, and this is called as short circuiting. Hence, we don't evaluate the second thing. Now, how do we know that B is minimum? B should be less than A as well as B should be less than C. Then I can conclude that B is minimum. Therefore, I write here ELSEF B is less than A and B is less than C. We can conclude that B is minimum. Is that okay? Now what is A? 10 less than 2. B is 2. 2 less than 10, yes. 2 less than 30, yes. And it prints B as answer. Now let us assume that C is minus 30. Now 10 less than 2, no. 2 less than 10, yes. 2 less than minus 30 is false. It means A is not minimum, B is not minimum, C should be minimum. Therefore, we write here else printf %d /n comma C, and here we may stop the procedure by saying return 0, and it will print C minus 30 as answer. Now, we will check, are we writing any duplicate conditions or something? Now please see over here, we are comparing A and B. Again we are comparing A and B, right? It is A less than B and it is B less than A. Anyway, we are comparing A and B. Now in ELSEF ladder, when do you reach the second condition? Only if the first condition is false. And in the first condition, we implicitly have checked A and B. Is it necessary again to check A and B? There is no point in checking B less than A. Therefore, I can remove this and I can write only B less than C. Now the question is, sir, will it work? Let us see will it work or not by taking B as minimum. Let's take A is 10, B is 2 and C is 30. Now you check here 10 less than 2, the condition is false. Now you have already checked A and B, there is no point in checking A and B. 2 less than 30, yes, 2 is less than 30, and you print 2 as the minimum thing, Let's take C as minimum, minus 30, 10 less than 2, it is false, 2 less than minus 30, it is also false, and it will print minus 30 as answer. Therefore, there is no point in checking B less than A again, because the second condition of the ELSEF ladder reach only if the first condition is false. This is how we find the minimum of 3 numbers. I want you to try the maximum of 3 numbers on your own similarly to this. And if you like the video, please click on the like button, comment on the comment section how do you find the video, share the video with your friends, subscribe to my channel. Thank you friends for watching this. Happy learning.